Okay. There. Now I think we're recording. That doesn't mean you can't talk. It's because I'm recording. Let's see here. All right, well, I'll wait a couple more minutes until we have our quorum. I know that Tessa won't be here today, so someone will have to fill in with the video and audio part. Someone brave. Also, I can't find Perry the Platypus today, which is weird. I wonder if it's connected to Tessa not being here today either. Very strange. We'll have to look into that. Okay. Well, if Tessa's not coming, is there anyone else who usually comes?
There's me.
Yeah, I see you. Well, I hear you. I see your A. And I guess that's it for the regulars. Well, as I said in my email, there's two things to go over today. One is to go over the solutions to the 11 problems on immunization. We're down to just two more topics. We're finishing up immunization, and then after we go over the problems, I'll start the lecture on interest rate swaps, which is the last topic that I'm going to cover, and it's really the last topic you need to know for FM. There's that paper that I sent out at the beginning of the workshop on determinants of interest rates, but that's just a 20-page paper to read the day before you take the exam. And so I'm breaking the interest rate swaps into two lectures. So next week we'll finish the lecture. And so at the end, I will send everyone a little homework exercise on the interest rate stuff so you can get up to speed. So when we do part 2 next week, it'll make more sense. Okay, well, that was a good introduction, Jeff. Thank you. All right, so let's see. The first question was, an insurance company has an obligation to pay $10,000 1 year from now and $10,000 2 years from now. And they have two bonds they can use as assets to back the liabilities. The first one is a 1-year coupon bond with 4% coupons. So that's what the cash flows from that one. You can pick any par value you want because it's all proportional. I usually pick a par value that will give me a low number of bonds needed. So if you picked 100, that's fine as long as you're consistent all the way through. So I'm assuming 1,000 for the par value, and so this one pays a coupon of 40, and then the 1,000. This is a 6% annual coupon, and it's 2 year. So remember how you do these. And this is an exact match of the 3 types of immunization. There was exact matching, Reddington immunization, and full immunization. And the way to do all of the exact matching is you have to start at the end and work backwards. So in this case, we need to cover 10,000 of liabilities. Our asset, each one is going to pay 1,060. So if you divide, we need 9.434 of those bonds, and that will generate 10,000. But if we have 9.434 of those bonds, each bond is going to pay a $60 coupon. So it'll generate $566 of cash flow at time 1. So if we look at the adjusted liabilities, which are the original liabilities minus what we got from the cash flows from the 2-year bond, we're left with nothing at time 2 because we've generated 10,000, and then we subtract the 566, so there's still 9,433 of liability that needs to be paid. And so from that, this is the cash flow remaining that we have. We take the liability, divide it by the asset cash flow, and therefore we need 9.071 of the 1-year bonds. And then now we've exactly matched the liability cash flows. And then the total cost of the assets, which is what the question was, is, well, it's the number of 1-year bonds times the price of the 1-year bond, and the number of 2-year bonds times the price of the 2-year bond. And since we've calculated all of that, you just find the price of each of the bonds and then multiply it out. And I got answer D, 18,594. Now be sure and just pipe up when you have questions on this. All right, I think the next one is another exact match. Oh, but it's over here. Zoop. Zoop. Okay, so for question 2, the liabilities are 10,000 in 1 year and 20,000 in 2 years. And the company has 2 assets again. One is a 2-year bond with a 5% annual coupon, and one is a 1-year bond with 6% annual coupon. So it's very much like the previous question. So the only difference is the amount of cash flow at time 2 and the amount of cash flows that each of the assets generates. So doing the exact same thing, you start at time 2, so 20,000 divided by the 1050. We need 19.0476 of those bonds. And then each of those bonds will generate $50 of coupon payments, which totals 952. We subtract that from the 10,000 that we have in liabilities, and there's a remaining 9,047.62. Now each of the 1-year bonds will generate 1060, so we need 8.5355 of the bonds. And so the question for this one is, what is the par value of the 1-year bond that should be purchased? Well, I picked a par value of 1,000 just to get numbers that are easy to do math with, but it's all scalable. So if we have just one bond, well, I've summarized it here. If the par value is 1,000, we need 8.5355 bonds. Therefore, if the par value is 8,535, we need 1 bond. So we're assuming, or the question is, you have 1 bond, what is its par value? So it would be 8,535. The closest answer would be B, 8,500. Right? Any questions on that? Even if you got 8.5355, all the answers are in thousands, so you would have got that anyways. All right, now we'll go back over to here for question number 3. It's very similar, but everything is in 6-month periods. So in this example, I think it was Joe. Yeah, Joe must pay 1,000 6 months from now and 1,000 1 year from now. There's the usual suspect, 2 bonds. The first one pays an 8% coupon, but it's semi-annual, so it's 1,040. This one has a 5% coupon, but it's paid semi-annually, so that's why it turns into 25. And each one has a different yield, but let's see, do we even need to know that? No. So the question is, calculate the number of bond 1 and the number of bond 2 needed to exactly match the liabilities. And so you probably see the pattern by now. We need 1,000, we have 1,025. So we need 0.97561 of the 2-year bonds. That'll generate 0.97561 times 25 in coupons. We have 1,000 liability at time 1. If you subtract the coupons, there's 975 remaining liability, and each of the 1-year bonds generates 1,040. So we need 0.93809 bonds. So in summarize, that's the number of each of the bonds, and that exactly matches answer D. Okay, so I think there's a couple more coming up, but it's not that hard to do one where it's exact matching. Each one is done the same. I mean, hopefully it's not a 20-year bond and you have to work all the way back. It won't be. It'll be a 3-year bond at the most. All right. Number 4 must be over here. It's just like writing on the board in class. Doesn't that look just like my classroom?
Yes.
I think it looks identical to my classroom.
Yeah, except for the Windows web screen.
Yes. I was going to say also, as you recall, the whiteboards, you just couldn't erase them. So one difference is there's not black streaks all over this like it would be if we were at school.
That's a benefit.
Yeah, you got to look at the bright side here. Okay, number 4, the liabilities. It's a $35,000 15-year annuity. And the company has only 2 types of assets. One is a 5-year zero coupon bond, and one is a 10-year zero coupon bond. The yield for everything is 6.2%, the assets and the liabilities. And it says that the liability has the same present value and duration of the asset. In other words, we're going to use Redington immunization. So obviously we can't do an exact match. There's no way you can take these 2 zero coupon bonds and match payments of $35,000 a year. That's impossible. So we can't do exact match. So even if we were not told in the problem that we couldn't do an immunization unless we used the property where the present value of assets is the present value of liabilities, the duration of assets is the duration of liabilities. Okay, so the present value of the liabilities is just 35,000 A angle 15, which hopefully I calculated correctly, is 335,530. And then to calculate the duration of the liabilities, well, this is, I think I said, if you recall from when we did the topic of duration, there's certain ones that you just need to memorize for types, like for coupon bond, the formula was Freonc over Frank. And there's formulas for perpetuities. Anyway, when you have a level cash flow, such as an annuity or a mortgage payment or something like that, the Macaulay duration is IA angle N over A angle N. So it's kind of like what it would be. That's why Freonc over Frank kind of has this IA in the top and the A in the bottom. There's no payment at time N, which is why there's no ANC at the end. And the amount of the payment will cancel completely. So there's no amount needed in front of those. So for those common types of assets or liability cash flows, like a bond or an annuity, you really should memorize the formulas for the Macaulay duration. You don't want to be deriving those each time. Okay, so it's a little bit of a shortcut. Because of this ratio, you don't even need the over I part, because the I and both of the denominators will cancel. So IA angle N over A angle N is just A double dot angle N minus NV to the N over 1 minus V to the N. And it's pretty easy to calculate. The A double dot you would do on your financial calculator. Calculate V to the 15th once. I write it here, and then I multiply it by 15 and write it there. So, because there's a V to the 15th in both spots. So it's pretty quick to calculate. The duration of the liabilities is 6.892. Therefore, we have two things we have to match for the assets. And remember the standard trick I went over last week is you let X equal the percent invested in one of them. And just out of habit, I let X be the percentage of the one with the shorter duration. So this one is 5-year, but it doesn't matter. You could have done it the other way around. So if X is the percentage invested in the 5-year zero coupon bond, well, the duration of a lump sum is just whenever that lump sum comes in. So asset 1 has a duration of 5 years, and asset 2 has a duration of 10 years. And so the weighted average duration of the portfolio is the percent invested in the 5-year times 5, and then 1 minus that percentage times 10. So when you multiply that through, you get 10 minus 5x. You set that equal to what we just calculated here, the liability duration, and you can solve for x. So this is the shortcut, so you don't have to set up simultaneous equations, and it saves about an hour of work. No, it doesn't save that much, but it's a great shortcut. And since the question is how much was invested in the 5-year bond, well, now we know that is we need 0.62159 of the present value, which of the liabilities. So we would need to put in 208,563, which is answer C, which is 208,600. And so as you can see, these aren't really hard types of problems. It's a topic that a lot of students skip, and it's sometimes my fault because I skip it during Finance 415, but it's a shame because they're usually not really complicated problems. All right, number 5, we're given an insurance company must pay the following liabilities: 99 1 year from now, 102 2 years from now, and 100 3 years from now. And they have not 1, not 2, but 3 bonds to choose from. One is a 1-year bond with a 7% coupon. B is a 2-year 0 coupon bond. So there's no coupon, so this is a 2-year 0 coupon bond. And bond C is a 3-year coupon bond with a 5% annual coupon rate. Now again, you can choose whatever you want for the par value. I picked 100 because that's the closest there is to the liabilities, so I get numbers that are not really small or really big. So now we need, oh no, this one actually says they all have a par value of 100 and they will be redeemed at par. So you might wonder, why did I write the yield rate under each one, which was given in the problem? Bond A has a yield to maturity of 6, bond B 7, and bond C has a yield to maturity of 9. We're going to need that because the question says calculate the number of units of bond A that must be purchased. So maybe we don't need to know that for this question. No, it doesn't. I thought it was going to ask how much does it cost or something like that. If it did, we would need that. But this one is just another exact match. So we do the same thing. We start at the end. In this case, we have 100 that's payable at time 3. And our cash flow at time 3 is 105. So we need 0.95238 bonds of the 3-year. And each one of those produces a $5 coupon payment at both times 1 and at time 2, which is 4.762. So the adjusted liabilities are the original liabilities minus the cash flows generated from bond C. And that wipes out the 100 at time 3. The 102 minus the 4762 leaves us with 97.238. And at time 1, it's 99 minus 4.762, which is 94.238. So now we are at time 2. The number of those bonds we need is just whatever the adjusted liability is, 97.238. Each one pays 100. So we need 0.97238. And there are no coupons for bond B. Therefore, the adjusted liabilities would now just be the 94238. And each asset, each of the 1-year assets pays 107. So the 94.238 divided by 107, you get 0.88073, which is answer 8. All right. Number 6 was a word problem. I told you a lot of the, well, certainly more so than in other sections, you need to know a lot of definitional stuff about immunization. So question number 6, it says, determine which of the following statements is true. So there's only one of these that's going to be true. A says Redington immunization requires that the convexity of liabilities is greater than the convexity of the assets. That's false, it's just the reverse. B, an advantage of Redington immunization technique over cash flow matching technique is that the portfolio manager has more investment choices available. That is true. With a cash flow match, you can only use 0 coupon bonds with maturity dates equal to the dates of the liability cash flows. Well, you can use some coupon bonds, as we saw, but for Redington immunization, there's anything you can use because you're just matching the duration of the assets to the duration of the liabilities. So there's more assets you can choose from if you're using Redington immunization rather than cash flow matching. So it's not true that you can only use 0 coupon bonds, but you always need to have an exact number like the ones we've seen before. Okay, C says both Redington immunization and full immunization are based on the assumption that the yield curve has higher yields for longer term investments. That's false, and it gets into the lecture for today. For Redington and full immunization, we must assume that yield curves are flat. For exact cash flow matching, the yield curve is irrelevant, so it's false. And D says a fully immunized portfolio ensures that the present value of assets will exceed the present value of liabilities with non-parallel shifts in the yield curve. It's false. For all immunization, the shift in the yield curve must be parallel. And when we get to yield curve, if you haven't already studied yield curves, a parallel shift means, if the original yields were 6%, now we're assuming interest rate changes. It changes by the same amount for every maturity date. So that's what I said here. It must be a parallel shift, which means interest rates change by delta I, that same delta applies for all maturity dates. And then E, a cash flow match portfolio requires less rebalancing than a Redington, but more rebalancing than fully immunized. That's false because exact cash flow matching requires no rebalancing. Rebalancing means as time goes by, your duration of your liabilities will change, and therefore you have to keep your assets duration in balance as time goes by. If you're doing exact matching, you don't have to worry about anything because you have that exact amount. It doesn't matter if time goes by or not. So you need to know a little bit of investing type stuff to answer those kind of questions. On we go then to number 7. All righty. We have a liability of $6,000 due in 4 years, and we have 2 assets. One pays $8 in 2 years and B in 6 years. And it says, employ a full immunization strategy using an annual effective rate of 5%. Calculate the absolute value of A minus B. Okay, so for full immunization, we need the present value of assets equals the present value of liabilities. The duration of assets is the duration of liabilities. The convexity of the assets has to be greater than the convexity of liabilities. And for full immunization, there's a 4th thing. Redington stops with those 3. Full immunization, asset cash flows must occur both before and after each liability cash flow. Well, based on this, 4 is obviously satisfied because we only have 1 liability cash flow, and we do have an asset cash flow both before and after. So we just got to make sure that 1, 2, and 3 are satisfied. The present value of the liabilities, well, the interest rate is 5%, so 6,000 divided by 1.05 to the 4th. What is the duration of liabilities? Well, there's only a single payment, so the duration is 4. And the convexity of a single payment is n squared. So if a payment comes in at time 4, its convexity is, where did it go? Oh, here, it's n squared. All right, and we do the same trick. Let x be the percent in the 2-year bond, or the time 2 cash flow, and 1 minus x would be the time 6 cash flow. So the duration of the assets, well, 1 comes in at time 2 times x%, the other one comes in at time 6 times 1 minus x%. you can solve that for X and you get 50-50. So we want 50% to be invested in the 2-year and 50% in the 6-year. So we got to calculate the convexity. And again, since these are bullet one-time payments, the convexity of this cash flow is 4. The convexity of this one is 36. It's just the time squared. So the convexity of the assets, since it's 50-50, it's 50 times 4 plus 50% of 36. It's 20. So the convexity of the assets is greater than the convexity of the liabilities. And now that we know that it's 50-50, we can calculate how much of this 49362 is invested in the 2-year. Well, for each of them, it's going to be 2,468. But the question wasn't, the question is, what is the absolute value of A minus B? So what we just calculated was what's the present value of A and what's the present value of B. So to get A and B, now we have to bring those present values forward. One of the answers is 0. And I can see that some people would get that as their answer, and it would be wrong. Because the present values are equal, that doesn't mean that A minus B equals 0. So to get A, you got to bring the time 0 value forward 2 years. For B, you got to bring that forward for 6 years. And now you can subtract, and you get 58641, which is answer D. Okay, so they're starting to get a little trickier. Number 8 looks like it's similar. A company owes 500 1 year from now and 1,000 4 years from now. The company will set up an investment program to match the duration and the present value of the above obligation using an annual effective rate of 10%. So here's the 10%. The investment program produces a cash flow of X today. That's kind of weird. Pays X dollars today. And Y dollars in 3 years. It says calculate X and determine whether the program satisfies the conditions for Reddington immunization. So it's a 2-step problem. So the first part is, what is X? The typical question, what is X? Well, the present value of the liabilities, since the interest rate is 10%, it's easy to calculate that. The present value of the assets, the X, because it's a times 0, and then Y brought back with interest. To calculate the duration of the liabilities, well, there's not a formula for I mean, if it was an annuity, we could use I angle N over A angle N. If it was a bond, we could use Frianc over Frank. But it's just 2 cash flows, so you got to find the duration one at a time. And the duration of the first one, well, it comes at time 1, so it's 500 times 1. It shouldn't be squared. And then times V plus the 1,000 comes in at time 4. So 1,000 times 4, and that's brought back for 4 years. So that is the numerator of the duration formula. And then the denominator is just the price, which we've already calculated. So the duration of liabilities is 2.8 years. And now we do the same thing. Let X be the total, the percentage invested in the time zero cash flow. Therefore, the duration of the assets is, well, it comes in at time zero times X. And then the other one comes in at time 3 times 1 minus X. And if you distribute that through, you get 3 minus 3X equals, and then you set it equal to the duration of the liabilities. From that, you get 3X is 0.198. So X, the percentage invested in the time zero, is a little more than 6%. And that times the present value of the liabilities says we need to invest, or the asset that comes in at time zero will be $75.36. So now we know the answer has to be A or B, because those are the only two that had X equal to 75. The other X's would be if you switch this around and used the 1 minus 0.066, then you would have gotten 1138, I think. All right, so the only thing we need to check for Reddington now, since we know that the present value of the assets equals the present value of liabilities, and the duration of the assets equals the duration of liabilities, there's only one more thing to check, and that does the convexity of the assets versus the convexity of the liabilities. So the convexity of liabilities, you got to do that just like you did duration. The only difference is, and that's why I accidentally wrote a square there, each of these time when the cash flow comes in gets squared, because it's the sum of n squared times the cash flow instead of n times the cash flow. So here's the 500 times 1 squared times v plus 1,000 times 4 squared times v to the 4th, all divided by the price. So you get a convexity of the liabilities of about 10 years. Now the convexity of the assets, now that we know 0.06624 comes in at time 0, it has a convexity of 0 squared. And then the rest, the 0.9376, comes in at time 3, so its convexity is 3 squared. And when you multiply that out, you get 8.404. So the convexity of the assets is less than the convexity of liabilities, and therefore Reddington is not satisfied. So hopefully you followed that logic. You knew the answer was going to be A or B, so if you didn't have time, you could guess, but it's not that hard to calculate the convexity when there's only 2 payments. So you could check that quick and see that Reddington was not satisfied. All right. I think number 10 was a fun one. I mean, I don't think 9 was fun. But... All right, so for number 9, it looks like we're back to an exact match. Our liability is a 3-year annuity of $402.11. And it says the company is going to invest $1,000 today to fund those payouts. So that's the present value of the assets is going to be $1,000. The only investments available are a 1-year 0 coupon bond and a 3-year 0 coupon bond. And the yield curve is flat 10%. The company wishes to match the duration of assets and the duration of its liabilities. Okay, so I guess this isn't an exact match. This is a immunization. So we were already told, I mean, I just checked to see the present value of the liabilities is 40211 times A angle 3, which is 1,000, which we were already told the present value of the assets is 1,000. So I'm glad that that worked out. That would have been ridiculous and a bad problem if they didn't match. If they said 1,000 was invested and the present value of the liabilities was different from 1,000, it would be a mistake in the question. All right, so we need the duration of the liabilities. This is an annuity, so we can use IA angle N over A angle N. We had one like this earlier. Here's the formula for A angle N, IA angle N over A angle N. And you get a duration of liabilities is 1.9368 years. You know, when you're calculating the duration of this, if you make a mistake and get an answer bigger than 3 or smaller than 1, an alarm should shriek in your head that when you have 3 payments at time 1, 2, and 3, the duration has to be somewhere in there. And if they're level payments, it's going to be close to right in the middle, which would be time 2. It's not exactly time 2 because there's a time value of money element to it. But keep in mind that duration has kind of a physical feel. So you can find out quickly if you made a mistake. All right, so I let X be the percentage invested in the 1-year bond. So the duration of the assets is 1 times X plus 3 times 1 minus X. And you get solve for X. X is 0.5316. And so we want the amount invested in the 1 year. So 0.5316 times the present value of the liabilities is 1,000. So we need 531.60 in the 1 year and 468.40 in the 2-year or 3-year bond. That's a typo. That should say 3-year bond, not 2-year bond. But all the answers had 3-year. So 532 and 468 is answer D. Number 10 was the fun one. All right, for number 10, the company ABC is required to pay its customers 20,000. Wait, that's number 11, sorry. Number 10, an insurance company wants to match its liabilities of 25,000 payable at time 1 and 20,000 payable at time 2. There's 3 assets to choose from, and I assume the par value is 10,000. Again, since the payments were in tens of thousands, I chose that. You could have chosen 1,000 or 100. It doesn't matter what you choose. The 1-year bond has a coupon of 6.75%. So it would have a payment of that amount. And it has a yield rate of 6. Oh, it says that that one is trading at par. So because it's trading at par, we know that the yield is the same as the coupon rate of 6.75. All right, the asset number 2 is a 2-year bond with coupons of 4.5%. So there's the 450 coupon and the maturity par value plus the last coupon. And it says it was sold at par. So that's how I knew that the yield on that bond is 4.5%. Bond 3 is a 2-year 0 coupon bond that has a yield of 5. And again, since I'm assuming a par value of 10,000 for each one of them, it's just going to have a payment of 10,000. Now the question is, calculate the smallest amount the company needs to disperse today to purchase assets that will exactly match the liabilities. So we're back to doing an exact match, because that's what the question said. And it's the only one where you can use different interest rates anyway. So what combination of this would produce the smallest present value? Well, let's look at how many possibilities there are. There's not that many. If we're trying to cover the 20,000 at time 2, remember, start at the end and work backwards. Well, we have to use either A2 or A3. So we have to do this twice. Once using A3, we can't use both A2 and A3. So we would calculate each one. All right, so obviously for this one, we would need exactly 2 of the 0 coupon bonds to match the cash flow, and it wouldn't produce any additional cash flow at time 1. So we would still have 25,000 in adjusted liabilities, and each of the 1-year bonds pays 10,675. So 25,000 divided by that, we would need 2.34192 of the 1-year bonds if we're using the 0 coupon bond to match the liability. And so the total cost, well, since each of A1 and A2 were issued at par, you don't have to calculate the price again. Since we assume 10,000 is the par value, that's also got to be the present value. So, and then the price of the 0 coupon bond is 10,000 divided by 1.05 squared, because that was the yield on that bond. So here's the total cost if we use A3. There's 2 of those bonds. Each one is 9,070. There's 2.34 bonds. Each one of these has a cost of 10,000. So the total cost would be 41,560. Now redo that, but instead of using A3 to match the time 2, we're going to use A2. So we need to calculate the number. We're now dividing by 10,450. So we need 1.913 of those bonds. And that bond has a coupon, so that 1.93 times the coupon payment of 450, that means that if we use A2, we're going to get a cash flow of 861.24 that we can use to offset the 25,000. So 25,000 minus 861.24 would be the adjusted liabilities, and each of the 1-year coupon bond pays 10,675. So we would need 2.2 of those. And now, since we're using both A1 and A2, the price of each one of those is 10,000. So here's the cost of the 1-year bond times 2.26, the cost of a 2-year bond times 1.93, and you get a total cost of 41,751. And so the smallest, it says what's the smallest amount? It would be this one, 41,560. Now, you might be asking, it didn't say you could only use one of these. What if you wanted to use both of these? Well, you can see from this that if you use a combination of the two, you're going to get a number somewhere between 41,560 and 41,751, because this is 100% and 100%. So let's say you use 50% of bond of A2 and 50% of A3. well, it would have a total cost exactly halfway in between. So that's why I knew I didn't have to test every single possibility, because if you do the 100% of each one, that's going to give you the max and the min of any linear combination of A2 and A3. All right. And then the last one was a fun one, a super duper fun one. Company ABC has to pay $20,000 after 3 years, and they have 4 different zero coupon bonds, A1, A2, A3, A4, that come in at time 1, 2, 3, and 4. Andy, the actuary, has to construct a portfolio that will fully immunize the liabilities. Okay, so the full immunization requirements, and it says that the market interest rate is 10%. So we have 4 conditions for full immunization. The present value of assets has to equal present value of liabilities. The duration of assets is the duration of liabilities. Convexity of assets is greater than the convexity of liabilities. And the 4th is that asset cash flows have to occur both before and after each liability cash flow. Well, there's only one. All right, and it says, determine the combination of zero coupon bonds that has the lowest sum of par amount. So the answers are 1 and 2. So it's the first answer is use these 2 bonds. The second answer says use 2 and 3. The third answer says use 3 and 4. The 4th one says use 1 and 4. And the 5th one says use 2 and 4. So those are the possible answers: 1 and 2, 2 and 3, 3 and 4, 1 and 4, 2 and 4. So let's start with the 4th requirement. We need to have asset cash flows both before and after the liability. Well, that means we have to use A4 because it's the only one that produces a cash flow after this liability cash flow. And so that means we have to use 4-year bonds and some of the 1-year or 2-year bonds. Therefore, the correct answer has to be either D or E, because you have to use, those are the only ones that use the 4-year bond, and C says use the 3-year and the 4-year. Oh no, it's updating my background apps. Oh. And my battery is low. Oh, geez. Okay, let's finish this question. Hopefully the battery won't die. Okay, so we know it has to be either answer D or E. Now let's check the duration and convexity parts. The liability has a duration of 3 and a convexity of 9. And so we need to find a combination that has a convexity greater than 9, because remember, requirement 3, the convexity of the assets has to be greater than the convexity of liabilities. So the first one to try, since the answers are down to either the 1-year and the 4-year or the 2-year and the 4-year. So first, in this case, I let X be the percentage of the 4-year bond, because we're going to do that twice. Then the duration of the assets, if we use the 4-year and the 2-year, so it's 4 times X, 2 times 1 minus X, we would need to use 50-50, we get our ratio as 1/2. So we would use 1/2 2-year bonds, 1/2 4-year bonds. If we use the 4-year and the 1-year, well, in that case, we would use 2/3 of the 4-year bond and 1/3 of the 1-year bond. So 2/3 4-year, 1/3 1-year. So we have different X values depending on which of these we use. So now we calculate the convexity of the assets under both of those. So the 16 is the convexity of the 4-year times, well, in this case, and then the convexity of the 2-year is 4. So the convexity of the combination of 4-year and 2-year would give us a convexity of 10. If we use the 4-year and the 1-year with the percentage equal to 2/3, then we get a convexity of only 7. So by checking the convexities, we can see that we need to use the 2-year and the 4-year, which is answer E. Okay, any questions on that? Let's see. All right, I have a few more minutes. I just want to briefly start the new topic because a lot of it is just notation. So I'll quickly cover this. So up to now, we've assumed interest rates are constant. And by that, I mean it doesn't vary by when the time of the cash flow is. If the cash flow comes in at time 1, or whether it comes in at time 3 or time 50, we've always said it's 6% or 7%. But in real life, interest rates don't work that way. A 5-year CD typically pays a higher rate than a 1-year CD. And a 20-year home loan would have a higher interest rate than a 3-year home loan. So that's why we need what's called a term structure of interest rates. So my notation is a little bit different from what the study note uses. I think mine makes a lot more sense. So in general, we're going to list interest rates in this fashion. We need to know 3 things. The interest rate will always be an annual effective rate, and it's the annual effective rate in effect from time T1 to time T2 as measured from this time. Almost always we're going to measure it at time 0. So this little guy there is 0. The only reason we need that is you only know interest rates as of today. Nobody knows what interest rates will be tomorrow or 10 years from now. So the only time you can actually measure interest rates are as of today. So why do we need this if we only know them as of today? Well, in some problems, it'll be, all right, now let's say 4 years have gone by. Well, if 4 years have gone by, at time 4, we will know what interest rates are then. And so if we needed to, I could put R4 to remind ourselves those are the actual rates 4 years from now. Okay, so we only know interest rates as of today. So here's a terminology. Those are known as spot rates. So anytime you see the word spot, here's spot. Spot rate is...
I'm gonna go now. Bye.
Okay, that's fine. I'm gonna have this on YouTube. I just wanted to go over this notation. I'll send the lecture out and the homework problems. I think you can get this from just reading my lecture. But I wanted to go over that notation. If today's time is the first time, then that's a 0. If this is a 0, we don't need a subscript anymore. So this would be the interest rate from time 0 to time t as measured from today. Okay, now after that, the rest I'm pretty sure you can just read. So I'll send this out. It's got examples I think it's pretty easy to follow. The main thing I wanted to go over was this notation. So you would know what it means and what a yield curve is. If you've had Finance 320, you already know what a yield curve is. All right, well, before everything crashes, I'll say good evening to you, and hopefully Tessa and Perry will be back next week. So I'll send out this lecture. It's only 7 pages, I think, and you can read through it, and then there's a couple practice problems, and then this is where we'll pick up for next week. All right. Well, thanks everyone for hanging in there. I'll stop sharing that, and have a good weekend. Let me know if you have any questions. Bye, everyone.